The National Electrical Code, or NEC, does not specify a maximum number of 15-amp circuit breakers in a single panel. However, it does provide guidance on the proper sizing and protection of electrical circuits. Circuits must be protected by overcurrent devices, such as circuit breakers or fuses, rated at no more than 150% of the ampacity of the conductors. For circuits supplying general lighting and appliances, the maximum circuit breaker amperage is typically 15 amps or 20 amps. The NEC does not specify a maximum number of circuit breakers that can be installed in a panel. However, it requires that the panel's bus bars be rated for the total amperage of all the circuit breakers it contains. It is generally recommended to limit the number of 15-amp circuit breakers in a single panel to between 12 and 18. This ensures that the panel's bus bars are not overloaded and reduces the risk of electrical fires. If more than 12 to 18 circuit breakers are required, consider using a subpanel or a larger panel with higher rated bus bars. Having too many circuit breakers in a panel can make it difficult to maintain and troubleshoot the electrical system. Overloaded circuits can cause the circuit breakers to trip frequently, resulting in inconvenience and possible safety hazard. To elaborate on the requirements, let's consider a more in-depth look at the subject. Firstly, the National Electrical Code, or NEC, serves as the cornerstone for safe electrical installations. It is important to understand that the NEC provides guidelines and regulations, but it doesn't explicitly state a maximum number of 15-amp circuit breakers allowed in a single electrical panel. The NEC focuses on ensuring that electrical systems are designed and installed in a manner that minimizes the risk of fire and electrical shock. Secondly, the primary function of a circuit breaker is to protect the circuit from overcurrents. Overcurrents can occur due to short circuits, ground faults, or overloading of the circuit. When an overcurrent happens, the circuit breaker trips, interrupting the flow of electricity and preventing damage to the wiring and equipment connected to the circuit. Thirdly, the NEC mandates that overcurrent protection devices, which includes circuit breakers, must be rated at no more than 150% of the ampacity of the conductors they protect. This means that if a circuit is wired with 14 American wire gauge copper conductors, which have an ampacity of 15 amps, the circuit breaker protecting the circuit should not exceed 15 amps. Similarly, if a circuit is wired with 12 American wire gauge copper conductors, which have an ampacity of 20 amps, the circuit breaker should not exceed 20 amps. Fourthly, the NEC requires that the electrical panel's bus bars be rated for the total amperage of all the circuit breakers installed in the panel. The bus bars are the conductive bars inside the panel that distribute electricity to the circuit breakers. If the total amperage of the circuit breakers exceeds the rating of the bus bars, it can lead to overheating and potentially cause a fire. To determine the appropriate size of the electrical panel, one must calculate the total load that the panel will be expected to carry. This calculation should include all the circuits connected to the panel, as well as any future circuits that may be added. It is essential to consult the NEC and local electrical codes for specific requirements and guidelines on load calculations. Fifthly, while the NEC doesn't specify a maximum number of 15-amp circuit breakers in a panel, it is generally recommended to limit the number to between 12 and 18. This recommendation is based on practical considerations, such as the physical space available in the panel and the potential for overloading the bus bars. A panel with too many circuit breakers can become crowded and difficult to work on. Furthermore, if all the circuits are heavily loaded simultaneously, it can exceed the panel's capacity and cause the main breaker to trip. Sixthly, if the number of circuits required exceeds the recommended limit for a single panel, it is advisable to install a subpanel. A subpanel is a smaller electrical panel that is fed from the main panel. It allows for the distribution of power to additional circuits without overloading the main panel's bus bars. When installing a subpanel, it is important to ensure that the feeder conductors connecting the main panel to the subpanel are properly sized to handle the load. Seventhly, in addition to the above considerations, it is crucial to ensure that all electrical work is performed by a qualified and licensed electrician. Electrical work can be dangerous, and it is essential to follow all safety precautions and applicable codes. A qualified electrician will have the knowledge and experience to properly size the electrical panel, install circuit breakers, and ensure that the electrical system is safe and reliable. Eighthly, overloading circuits can lead to various problems, including tripped circuit breakers, overheated wires, and potential fires. It is essential to avoid overloading circuits by ensuring that the total load connected to each circuit does not exceed the circuit breaker's rating. If a circuit breaker trips frequently, it is a sign that the circuit is overloaded and needs to be addressed. This could involve reducing the load in the circuit or adding a new circuit to distribute the load. Ninthly, when working with electrical panels, it is important to always de-energize the circuit before performing any work. This can be done by turning off the main breaker in the panel. It is also advisable to use a voltage tester to verify that the circuit is de-energized before touching any wires or components. Tenthly, it is important to periodically inspect electrical panels and circuit breakers to ensure that they are in good condition. Look for any signs of damage, such as cracked or broken breakers, loose wires, or corrosion. If any problems are found, they should be addressed immediately by a qualified electrician. 11th, another consideration is the type of loads that are connected to the 15-amp circuit breakers. General lighting and receptacle circuits are typically protected by 15-amp or 20-amp circuit breakers. However, some appliances, such as refrigerators, dishwashers, and washing machines, may require dedicated circuits with higher amperage ratings. The NEC provides specific requirements for the sizing of branch circuits for various types of loads. 12th, the location of the electrical panel is also an important factor to consider. The NEC requires that electrical panels be readily accessible and not located in hazardous locations, such as bathrooms or closets containing flammable materials. The panel should also be protected from physical damage. 13th, when installing new circuit breakers, it is important to use the correct type and size of breaker for the panel. Circuit breakers are designed to trip at a specific amperage rating and have a specific interrupting capacity. Using the wrong type of breaker can compromise the safety of the electrical system. 14th, it is also essential to label all the circuit breakers in the panel clearly. This will make it easier to identify the circuits and troubleshoot any problems that may arise. The label should indicate the area or equipment that each circuit breaker serves. 15th, the NEC also includes requirements for ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect people from electrical shock by detecting ground faults and interrupting the circuit. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. 16th, arc fault circuit interrupters, or SIs, are another type of protective device that is required by the NEC in certain locations. SIs are designed to detect arc faults, which are dangerous electrical arcing conditions that can lead to fires. SIs are typically required in bedrooms and other areas where people are sleeping. 17th, electrical panels should be installed in a dry location and protected from moisture. Moisture can cause corrosion and damage to the electrical components, which can lead to safety hazards. If the panel is located in a damp or wet environment, it should be enclosed in a waterproof enclosure. 18th, electrical panels should be properly grounded to provide a path for fault current to flow back to the source. Grounding helps to prevent electrical shock and reduce the risk of fire. The grounding system should be installed in accordance with the NEC and local electrical codes. 19th, electrical panels should be inspected periodically to ensure that they are in good working order. The inspection should include checking for loose wires, damaged components, and signs of overheating. Any problems should be addressed immediately by a qualified electrician. 20th, when adding new circuits to an existing electrical panel, it is important to consider the capacity of the panel. The panel must have enough available space and amperage capacity to accommodate the new circuits. If the panel is already full, it may be necessary to install a new panel or subpanel. 21st, electrical panels should be installed in accordance with the manufacturer's instructions and all applicable codes. The instructions will provide detailed information on the proper installation and wiring of the panel. 22nd, electrical panels should be installed in a location that is accessible for maintenance and repairs. The panel should not be blocked by furniture or other obstructions. There should be enough space around the panel to allow for safe working conditions. 23rd, electrical panels should be protected from physical damage. The panel should be located in an area where it is not likely to be struck by vehicles or other objects. If the panel is located in an area where it is subject to physical damage, it should be protected by a barrier or enclosure. 24th, electrical panels should be installed in a location that is away from flammable materials. The panel should not be located near gasoline, propane, or other flammable liquids or gases. If the panel is located in an area where flammable materials are present, it should be protected by a fire-resistant enclosure. 25th, electrical panels should be installed in a location that is away from sources of heat. The panel should not be located near furnaces, water heaters, or other heat-producing appliances. If the panel is located in an area where it is exposed to heat, it should be protected by a heat shield. 26th, electrical panels should be installed in a location that is away from sources of moisture. The panel should not be located near sinks, showers, or other sources of water. If the panel is located in an area where it is exposed to moisture, it should be protected by a waterproof enclosure. 27th, electrical panels should be installed in a location that is away from sources of vibration. The panel should not be located near machinery or other equipment that produces vibration. If the panel is located in an area where it is exposed to vibration, it should be protected by vibration-dampening materials. 28th, it's essential to stay informed about updates and revisions to the National Electrical Code, as it is periodically updated to reflect advancements in technology and safety practices. Consulting with a qualified electrician or electrical inspector can provide valuable insights and guidance on specific requirements in North Carolina. Remember, safety should always be the top priority when working with electricity.